Well, hello again, everyone. Mr. Reeves back with you one more time. And today I'm going to be making a really quick video showing you how to use theoretical probability to make predictions. All right, so I'm just going to go ahead and work through some examples from IXL because if you understand how to find the probability of an event, then it's just one more step if you're going to make a prediction. So let's just take a look right here. We're going to dive right in. It says if you flip a coin 12 times, what is the best prediction possible for the number of times that it will land on heads? All right, so let's go ahead then and take a look at this problem. All right, so it says you're going to flip a coin 12 times. So the first thing you need to pay close attention to is how many times is this event occurring? It's occurring 12 times. And then what is it that we are trying to have happen? We want it to land on heads, all right? So we're going to actually start with the second problem, part of the problem, excuse me. And let's talk about the probability of getting heads. So if you flip a coin, what is the probability of getting heads? Well, the probability of getting heads is 1 out of 2. All right, and then what do we have? We have the number of events. How many times are we doing this event? We're doing it 12 times, right? Flipping the coin once, we're flipping the coin twice, we're flipping the coin 3 times, 12 times. And every time we do it, what is the probability that we get heads? A half, right? So if we want to make a prediction for the number of heads that we're going to get, right? So our prediction is going to be the probability I always have such a hard time spelling that word. I always forget it has 2 B's. The probability times the number of events. Okay, so here we go. So what was the probability? The probability of getting that heads was 1/2. How many times is this event occurring? 12 times. And so the answer is 6, right? Which should make sense because we get heads half the time, or approximately half the time. At least that's what the theory says, right? And half of 12 is 6. So let's go ahead and put that answer in. And let's take a look at the next problem. It says you select a marble without looking and then you put it back. If you do this 12 times, what is the best prediction possible for a pink marble? All right, so once again, if we take a look at the number of events, right? We have 12 times we are doing this event. And what is it that we are trying to get? We are trying to pick a pink marble. So the probability of getting a pink marble without looking, all right? So how many pink marbles do we have? 2. So we have 2 winning outcomes. How many total marbles do we have? We have 3. So every time we reach in and grab a marble, we have a probability of 2/3, or we have a 2 out of 3 chance that we're going to get a pink marble, right? How many events are we having? So the number of events is once again 12, right? So what are we going to do? What did we do previously? We're going to multiply, right? We're going to take the probability, 2/3, and we're going to multiply it by 12. All right, I'm going to go ahead and put this 12 over 1. And when you multiply a fraction times a fraction, you can multiply and then simplify, or you can simplify and then multiply. I like to simplify first. 12 divided by 3 is 4, or 3 goes into 12 4 times. 3 goes into 3 1 time, by the way. And now when we multiply straight across, we get 2 times 4 is 8 over 1, and it is 8. So out of those 12 times, we would expect 8 times that we would get 2 pink marbles. All right, because 2/3 of 12 is 8. All right, so let's go ahead and skip up to the next level here. You select a marble without looking and then put it back. You do this 4 times. What is the number of times you will pick an orange or a blue marble? Okay, so again, let's look at how many events we have. We have 4 events, and let's take a look at our probability. We want probability of orange or blue. Probability of orange or blue. All right. Okay, so let's take a look at this. Hopefully you've had a chance already to do the previous lesson, which is probabilities involving orange. All right, so if we take a look at these separately, what is the probability of getting an orange? And what is the probability of getting a blue? Well, I'm looking at these marbles and goodness gracious, I'm not seeing an orange anywhere. So the probability of getting an orange is 0 out of 4, right? And the probability of getting a blue, I'm looking and seeing 1 blue out of 4. And since you can't pull an orange marble and a blue marble at the same time, these are what we call mutually exclusive events. And so the probability of getting an orange or a blue is the same as adding these two together. If I add these two together, that's going to give me this probability right here. Well, 0 out of 4 plus 1 out of 4 is 1 out of 4 because there are no orange, right? So actually it doesn't even matter. We could kind of just ignore that, right? So the probability of getting an orange or a blue, okay, I'm going to abbreviate orange or blue. All right, so the probability of getting orange or blue is equal to 1/4. Okay, so we have a 1 out of 4 chance of getting what we want. We're doing it 4 times. So our prediction based on the theoretical probability, 1/4 times 4, if I go straight across, I get 4 out of 4 or 1. So in theory, we should, out of those 4 times, one of the 4 times, we should get what we're looking for, which makes sense, right? 4 marbles, 1 blue. Cool beans. All right, you select a marble without looking and then put it back. If you do this 9 times, what is the best prediction for the number of times you will pick a pink marble? So again, pink would be 1 out of 3, and we're doing it 9 times, right? So it'd be 1 out of 3 times 9. Well, 1/3 of 9 is 3. All righty. So how about this one? Oh man, what's the number of times it's going to land on blue? How many blues are there? There aren't any blue, are there? You can't get a blue ever. I could spin this spinner infinitely many times and I'll never get a blue. All right, that was way too easy, IXL. Okay, so I'm going to skip up to the next level and see if they've got one that's a little more difficult. All right. Oh my goodness, this is just the opposite of the one we did, right? Here we're spinning the spinner 20 times. So that's our number of events, right? There's our number of events. And the probability we're looking for that it will land on green or pink. We'll take a look at this spinner. Everyone is either green or pink. So if I spin it, right, it's either going to land on green or pink. I know what some of you are thinking. Well, what if it lands on the line? Well, if it's in the middle, it's got to count as green or pink, right? There's no other colors. So we have a 100% probability, all right? No matter how many times we do this, we're always going to get a green or a pink, right? So how many times, since we do it 20 times, 20 out of 20 times we would expect to get a green, or a pink. All right. Okay, here's one that's a little more interesting, and we'll finish up with this one. If you spin a spinner 24 times, what is the best prediction for the possible number of times it will not land on green? It will not land on green. All right, so first off, our number of events is 24. And what are we looking for? That it will not land on green. So let's find this. Let's find the probability of not green. The probability of not green. Well, the probability of not green is going to be the same as the probability of what? Which ones are not green? Probability of yellow or what? Pink, right? You guys agree with that? There's only three colors. There's yellow, pink, and green. So if it's not green, it's yellow or pink. And these are mutually exclusive because it cannot land on yellow and pink at the same time. I know what you're thinking. Well, what about if it lands on that line right there? All right, so when I was a kid and we played the game, if it landed on the line, right on the line, all right, we would spin it again. Okay, so we're gonna say it spins only count if it's on a color. All right, so the probability of yellow or pink is going to be the same as the probability of yellow plus the probability of pink, right? Because these are independent events. They are mutually exclusive. It can't be both at the same time. All right, so how many total sections do we have here? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so we have 12 total outcomes every time we spin it. How many of those outcomes are yellow? 1, 2, 3, 4. How many of those outcomes are pink? 1, 2, 3, 4, 5 are pink. So the probability of landing on a yellow or landing on a pink is 9 out of 12. And we should be reassured because we can quickly see there are 3 green. And if we added the 3 to the 9, we would get 12 out of 12. All right, so 9 out of 12 times, we are going to get not green. Now 9 out of 12, we can divide 9 and 12 both by 3, and we get, when we divide 9 by 3, we get 3. When we divide 12 by 3, we get 4. So 3/4, or if you prefer, we have a 75% chance of getting not green, right? Okay, but how many times are we spinning this spinner? Now we go to the event. It's 24 times, right? I'm going to go ahead and put that 24 over 1. And once again, we can multiply and then simplify, or we can simplify and then multiply. And I usually prefer to try to simplify first. 4 goes into 4 one time, or 4 divided by 4 is 1. 24 divided by 4 is 6. And when we multiply straight across, 3 times 6 is 18, and 18 over 1 is 18. So out of those 24 times, when we spun that spinner 24 times, 18 of those 24 times, we would expect it not to land on green, which means 6 out of those 24 times it would. And that is super, and that's what we're going to end this video with. Thanks for watching. Sure hope this helped you out. Have a great day.